so we talked about vertex and standard form in class, but now we're going to go through and see how do you convert from one form to another. All right, so this guy over here. What I have here is a step-by-step walkthrough. Let's see, it's going to be a little bit cut off with this thing, so let's move it over a little bit. Here we go. Okay. So let's walk through a problem here. This is the 4 steps that you're going to go through in order to convert from vertex to standard, not standard to vertex. And hopefully it's pretty clear. Okay. So let's start with problem. Let's say the problem is y equals 3x minus 2 squared plus 5. Okay. The first thing you're supposed to be doing is to write out the square. Now, what I see a lot of students have trouble with is they want to distribute first. Okay, they either want to put that 3 inside the parentheses, or they want to apply the square directly, something like this. Okay, let me just write it out and tell you that both of these steps are incorrect steps. Okay, so if you're inclined to say that this is y equals 3x minus 6 squared plus 5, that would be incorrect, okay? If you want to say this, y equals 3x squared minus 4 plus 5, that would be incorrect as well, okay? That is not how you apply a square. So, in order to do this correctly, you have to actually remember what it means to square something. To square something means to multiply it by itself. So the first thing you do, and I specifically say write out, okay? So the only thing you should be doing is defining what it means to square something, which is to multiply it by itself. Okay? So I see that we have x minus 2 quantity squared. That means it's going to be x minus 2 times x minus 2, okay? Which is not any of those products that we saw before, okay? In order to do this step now, we go back to something I showed you a couple weeks ago, which is you have to either FOIL or Punnett square, okay? So, if you like the Punnett square, go ahead and build your square off to the side here, okay? And you do your x minus 2 and x minus 2, okay? That's fine. What I'm going to do is I'm going to actually FOIL just because it saves me a step and a little bit of writing, okay? So I do x times x and x times negative 2. It's like a fancy distribution. You're going to be multiplying one of the x minus 2's by each of the x and the negative 2, okay? So either way, whatever you're doing 4 sets of multiplication. Okay, so let's write this out now. We have y equals, the 3 comes down, that's the same. We're going to have a big product in here, plus 5. Okay, so what is that product? Well, let's see. We have x times x, that's going to be x squared. We have x times negative 2, that's going to be negative 2x. We have negative 2 times x, that's also going to be negative 2x. And then finally, we got negative 2 times negative 2, that's positive 4. Okay? So that's going to be step 2, is to actually FOIL that out. Now, go ahead and take a second and combine your like terms on the inside. So that's going to be y equals 3. X squared doesn't have anything to go with it, so it's just going to be x squared. Then we have negative 2x, negative 2x, that's going to be a total of negative 4x. Plus 4, plus 5. Okay? Again, when you FOIL 2 binomials, you should have a trinomial at the end. At least as long as you have a couple of like terms on the inside. Okay? Alright, so now we got next step, which is going to be distribute A. Now we finally come back to that first coefficient and we distribute. Okay? So now we go ahead and distribute that 3 into everything. So, as our result here, we should have y equals 3x squared. And then we're distributing again, minus 12x here. We are going to be adding our k value. Again, just kind of a combine like term step. This is going to be y equals 3x squared. Let's see, minus 12x plus 17. That's what happens when you add the two. And notice this is in our standard form, ax squared plus bx plus c. So that's the form that we actually would like to have. Okay? So this process does not change at any given point. This is going to be the same steps each time, just with different numbers. Okay? So that's pretty straightforward. Right? Okay, so now if we're starting in our intercept form, we are going to want to convert back to standard form as well. Okay, so let's do an example of what you wanted to do there. This one's actually a lot easier going from the intercept form back to standard. So let's see, let's say we have an equation here of y equals 3 times x minus 6, x plus 3. Okay. So the first thing you're going to want to do is you're actually going to want to FOIL first. I know some of you want to distribute right off the bat, but it's actually going to be easier. You could, you just have to be very careful. But so I'm just going to say as a standard, just go ahead and take care of your FOILs first. Always take care of your FOILs if you have two binomials that you're multiplying together. Okay. So again, if you need to go up to the side and do your Punnett square, that's fine. Okay. Otherwise, I like to do my foiling. By the way, if you've never heard of foiling, it stands for first, outside, inside, and last. Okay, that's why we call it foiling. It's you do your first terms together, then you do your outside terms, in other words, the x and the 3, then you do your inside terms, the negative 6 and the x, and then you do your last terms, the negative 6 and the 3. Together. Okay, so moving on here, looks like we've got y equals 3, and then you have an open parentheses with a lot of stuff happening in between. X times x is x squared. X times 3 is 3x. Negative 6 times x is negative 6x. And negative 6 times 3 is negative 18. Okay? Go ahead and take a step and combine your like terms. So that's going to be your inside terms here. We're going to have x squared minus 3x minus 18. Okay? Then the last step, now we move on now, we can now distribute that a value. So here we are, y equals, we have 3x squared minus 9x. Let's see, minus is 54? I think so. Okay. And here we are with our final answer again. So this one's a little bit easier to go through. Now, here's the question. We have both of the forms we have, we can convert back to standard. Okay? Now, is it possible to go from standard to vertex and from intercept to vertex or to standard into either of the other directions? And the answer is yes, we can. Okay? All right, so this next one is a little bit more complicated going from vertex to intercept form, okay? And you have to be kind of careful on the values that you pick because as of right now, as for now until about the end of second quarter, there might be some vertex forms that we cannot convert into intercept form. And in class, I'll tell you what to do if that should happen, okay? So go ahead, somebody remind me in class tomorrow as to what would happen if you have something that would go wrong, okay? So let's go through an example though, because we have sets that do work here. So we have y equals 2 times the quantity, let's say x plus 3 squared, let's say minus 18. Okay, that's going to be a good set here. Okay, so the first thing that we do, it says plug in 0 for y and then solve for x. Okay, so I also wrote parenthetically the process in which to solve for x. Okay, and it's very important that you follow that process every time. Okay, So the first thing we do, plug in 0 for y, and we had equals 2 times the quantity x plus 3 squared minus 18. Okay, so let's follow this one step at a time. I'll underline in blue here. Okay, first we subtract our k value. Okay, so our k value is negative 18, so subtracting a negative 18 is like adding. Okay, so really when you think subtract k, you might be thinking adding k to it. Whatever it is, get rid of k first. Okay, so we have 18 is equal to 2 times the quantity x plus 3 squared. Okay, hopefully that's clear on when I say subtract k. Really what I'm trying to say is get rid of k. Alright, next step, we should be dividing by a next. Okay, because this is a reverse PEMDAS. We're going backwards from PEMDAS when we do algebra. Okay, so we're dividing by 2 here, dividing by 2 here. So it looks like this is going to be 9 on the left, and this is going to be x plus 3 squared on the right. All right, very important step here, and again, I gave them in another parenthetical process here. It says take the square root, and when you take the square root in algebra, this is a very important fact. Okay, when you take the square root in when you're doing algebra, you have to include both the positive and the negative roots. Okay, because just off to the side here, let me show you what I mean. If I have x squared equals let's say 16. Yes, one answer to this question is 4, okay, and you get that by square rooting both sides. However, another answer to this question is negative 4, okay? So we have to include both answers when we do algebra, okay? So if I just ask you what is the square root of 16, yes, that is 4. That's fine, that's an acceptable answer. There's only one answer for a square root. But when we're doing algebra, you have to include both answers because we are looking for all possible solutions to that, okay? So let's see, if we go, I don't want to mess with that, okay? Let's just erase. All right, erase that, okay. Moving on now, let's move on. We got blue after this, so we're going to square root both sides. Okay, so on the right-hand side, we should have what we wanted left over, x plus 3. And then the square root of 9 when we're doing algebra is going to be plus or minus 3, okay? There's going to be a positive 3 and a negative 3 as a result, okay? That's where we're seeing the two answers with the square root, okay? So now we're going to subtract 3 as the last step here, okay? Or add h, again, it doesn't matter, all we're trying to do is get x by itself. So we're going to have x equals, let's see, when 3 is positive, subtracting it will be 0. And when 3 is negative, subtracting another 3 will give us negative 6. Okay? Hopefully that's clear on what we had to do there. Okay, so it says we should get 2 answers with the square roots, and we do. Okay? So next step is we keep our a value. Okay, so remember, our standard, or our general form for the intercept is y equals a quantity x minus d, x minus e, okay? That's what we have to do, okay? So next thing that we're going to want to do here is we're going to want to plug in all of our values, including a, okay? So a here, a we can find back in the original problem right here. Okay, so we're going to keep that as we plug in. So that's going to be 2. Next, we're going to plug in the answers for D and E. Okay, so minus the first answer is 0. And the second answer, x minus negative 6. Okay, now, technically that is the correct answer here, but we're definitely going to want to do some cleanup here. Okay, so we have y equals, let's see, this right here, x minus 0 is just going to be x. So this is going to be 2x on the outside, and on the inside it looks like we're going to have x plus 6. Okay? And that's totally acceptable in terms of intercept form. If you want to keep the x minus 0 to remember, oh hey, my intercept is going to be 0, that's acceptable too.